Hello there, guys. Okay, so we are here on this webinar. So let's focus on the slides. So I will turn off the videos so that it will not be distracting you. And also I can switch to the bigger screen for myself as well. So 2 seconds, let's bring it up. So okay, and okay. Just 2 seconds. I'm trying to switch to the bigger slides. Okay, and I am going to turn off the video. So stop the video. All right, guys. So this is the target. This is the kind of topic which is highly sought after, basically, because I will just put it on that screen as well. And I'm going to minimize everything else so you can see better. Okay, let's see if we can clear everything. So it is the kind of short presentation for a very complex topic. The topic is actually extended reach drilling, which is quite complex. You can imagine if you are planning this well. I have been in the some of the companies department where people are planning for 2 years. Some people were planning for 3 years. And those wells were very, very complex. You are looking at MPD, turn and twist of the sections. They are turning like an elbow, basically. Complex, really complex wells. You can plan them for 2 years. And when we went on drilling, the same well had been planned by a group of highly experienced people. They thought they got everything done. Okay. They did not. When they drilled it, everything was a disaster with this well, with all the plannings from very, very sophisticated, very big company I'm talking about. So it's a very interesting topic. If you like problem solving, you have come to the right place, my friend. ERD, extended reach drilling. It depends what is the character of your ERD well. If your ERD well is just benign, they are not too complex, then you will be saying, okay, ERD, I got it. I know everything about it. But sometimes the type of ERD you're drilling is a killer. It takes something. So be kind of aware of these ERD type of wells. Some wells are easier, some wells are harder. When it comes to the difficulty of a certain complex wells, they can actually throw off even the experienced teams. And all the planning goes down the drain. Then you keep fighting to make it happen. To drill those wells can take a nightmare. And most important thing, when you're drilling them, be open to change and fix the problem by finding the solution when you are drilling them. A lot of the drilling people, they have a plan. They are on autopilot. They say, oh, I will follow the plan. I will not budge, not left, not right, nowhere. I always follow the plan. Yes, but if all the signs are telling you your plan is not working and you have something fundamentally wrong, you have to change the plan. Okay, so this kind of ERD kind of things are really, really great to learn and appreciate the difficulty it brings to the table. And we need to be open as well. We need to be flexible when we are doing it. When we are drilling them, we have to be open. Same, I would say, for the planning. So if you are a student or younger person, be open and flexible and don't be rigid, because experienced drilling people suffer from rigidness, not changing too many things, thinking not out of the box. You need to think out of the box to solve certain problem. People have done extremely fantastic jobs, basically, by thinking out of the box, solving problems related to ERD, and then they have very high quality, cheaper wells. So let's talk about this. And the goal for this is to give you a flavor, not to make you a master of everything. However, once you have gone through this 1 hour with me, you will have a feel for what to look out for. You can contribute to the team, and you can even stretch out to us and ask us a question. because I also like problem solving. So agenda for this one is the introduction of the topic, introduction about myself, excuse me. And then we talk about extended reach, drilling success factor. When you say success factor, I mean to say you must get them right, the building blocks. If one of the building block is crooked, whatever you do might not work. So it's a very important and something to remember to make this right. Okay. And I'm sure you will, because what we had in the past is people are afraid of too much data. In the past, for last 20 years, I have been around for only for the last few years. People are not afraid of the data. People say, dig out all the data, give me everything. And they go about problem solving with the data, machine learning and artificial intelligence, finding the patterns and things like that. So you are in luck, actually. You don't have to suffer through the old-fashioned approach. So the approach that I will be showing you is modern, actually. I found it working. I found it people using it. It's a common sense approach, but with the infusion of data, how you use it to your advantage and problem solving. Okay, so it's a very nice kind of area to work in. I know some drilling engineers only work ERD because they have become great at it. They are not common drillers. They sometime on the rig floor. They are sometime doing all kind of things to solve the problem because they are specialists. And same with the consultancies. There are consultancies, they only do ERD because they know how to do it. Other people do not. They get hired. All of them get hired everywhere. So approach is important, as I mentioned, and so is roadmap. Roadmap for optimization, anybody can plan the well, but think about it. You can copy and paste from somewhere, or you can follow your experienced engineer's guideline for ERD. I would not be worried about it. I say, yes, let's go with what we already know. We know how to do this in the past. How about optimization? Could you optimize it? Optimization does not have to be a controversial topic. But if you have very expensive $60 million well, it could be controversial because people don't want to risk. When you optimize, sometimes you optimize it for wrong reasons. Okay, so they could be correct, actually. People could be correct that you should not optimize something when it jeopardizes the rest of the delivery of the well. Okay, so it is important to appreciate optimization as an art. You optimize according to your experience. You say, I have seen this in action. I have seen this optimization work. Let's go do it. But how about the risks that your well had previously are different from the risk this particular well you are trying to optimize? So it's an art. You cannot just take this and plug this into that one. There you go. You optimize all of them like this. It does not work like that. Drilling business is quite complex, and you need to be appreciative of these versatile challenges that each well brings. There was an experienced driller once told me, we plan the well almost the same way. However, we drill them, we find them different. All of them, most of them different. So it's a kind of good explanation. Selection of technologies and BHA component for ERD wells. Since they are going extended reach, you are extended, you are pushing the boundaries. When you push the boundaries, you need a strong arm. And that strong arm is your BHA and the string. It could be the technology that you put it in the system. So just to be aware of these things, that these kind of wells can push the boundaries. You cannot just use what you have been using. And also, we did not touch on one thing, the measurement of parameters. If you're drilling normally, you have certain measurements. If you're drilling for ERD, You may want to enhance the portfolio of that measurement. You want to see the downhole better for the parameters you are after. Because in the normal drilling, you may not be worried about downhole weight on bit. You may not be too much worried about downhole torque measured by sensors. But here in ERD, it's gold. This is what you need. Why? Because you have an eye in the borehole. That way, you are seeing the problem that the BHA is negotiating. I did not touch too much on it because this is a separate topic, LWD, MWD, because this is your visibility into the kind of, borehole environment. If you mess up the borehole environment, you're going to have a big problem. It will not let you drill through. And sometime you get stuck, it will not come out of the hole. So it's a very strange thing that the mother nature is not so motherly if you do not watch them, how things are. And when the things start to go south or going something not right, you better know straight away. How would you know? Because you have these sensors. Some people want to cut corners when they're drilling. They say, hey, these sensors, they are fancy. I don't want to pay for it. But they have to pay the price for these things. So having more information is better than less information. So this is the rule of thumb. And trust me, it's cheaper than getting stuck or what. So I will touch on some of those. Yeah. Okay. So question and comments. I would like to be a little bit generous there to be able to answer some of the questions, because questions are actually fill the gaps in the knowledge and also start the good conversation. So we will have this 10 to 15 minutes at the end, which I endeavor to stop in 40 minutes or so. So we'll continue to go and explore this topic. Okay. So about myself, Nikhil had mentioned, I've been around for some time, 20 something years now. And I've got MSc in petroleum engineering from the University of Oklahoma. After studying, people sent me offshore. Why they would send me offshore? Because I was from my own country. So all the guys who were there, they got very nice reservoir engineering and petroleum. They say, this guy is from outside, so send him offshore in the USA. Okay, so I went offshore. That was actually a blessing in disguise. I got to see all the complex rigs, complex wells, deep water, and all kind of fantastic teamwork that you learn on the rigs, how the things are being done on the rig. Just by thinking about it, it's different. It's completely, when you have perception of the rig, you will feel that way. People do it in certain framework. When you work there, it's fantastic. Actually, it's totally different from what other people might perceive about the rig. Extreme teamwork, extreme joining hands, supporting each other. All of them are doing and contributing to just one thing: drilling, optimization of drilling, supporting each other, getting it. We had meetings every 12 hours. We hold hand before we go into our 12-hour shower, this tower, and mention this, that we pray that everybody stays safe. We pray that we will help each other. We promise you our those kind of words and nice prayers that people used to go with. And this is a great teamwork exercise. So I really enjoyed this 6-7 years working offshore, floating rigs, deep forests in Texas, Louisiana, Mississippi. There were also different experiences. Optimization was my thing, directional planning and everything. Okay. So we will talk about, also I have got experience working in various offices. When I moved to the UK, I had a lot of experience working in offices where I saw ERD wells, lots of ERD wells, people drill with them. I had a first-hand experience dealing with the problems that other people have designed. I have designed also some bad ERDs myself. I have to say that because I am also human. If other people can design bad ERD, I can also design be a bad ERD. So we have learned through these last 20 years. So it's a kind of fun journey. If you would like to get in touch, feel free to ask any questions, technical or otherwise. We can talk about those. About the ERD wells, those are kind of defined in certain ways. People say an ERD well is everything is in the name. Actually, if you think about it, there is no mathematical formula that if it qualifies this, this is an ERD well. That would not probably be the right way to say that. So there's no definition, but people say when you're drilling them, you know what you're drilling. So it's a lateral departure. If you plot TVD versus your lateral, or let's say departure, or let's say step out, people call them step out. Step out is the distance from the origin of the well to where it is at the moment. If you're drilling a well, there is an origin where it started, the vertical thing, vertical location, and where it ends. At the total end of this is there is a horizontal displacement. This is called lateral displacement, or people call them a fancy name, step out. Step out is more something you can visualize. When you're stepping out, you are stepping out of your origin. They say the ratio between this horizontal departure to the TVD is 2.0, like more departure, a lot of departure is going away from you, from the system. So it is, so measure depth to TVD ratio. There is another metrics people use is measure depth to TVD 2.0, but don't worry too much about it. Shallow ERDs, you kick off shallow and become horizontal or become high angle well. So those have very difficult challenges in the North Sea, in the Captain field. I did some work for those shallow ERDs. You cannot even run in the hole because of the drag. You try to run it, stop running because you got horizontal right away. Kick off quickly, shallow, become horizontal. Can you run in the hole? No. How would you drill those wells? So there are technologies people use, there are methodologies people follow, and they drill those wells. There was a master thesis on it. I also supported them for that kind of analysis. ERD well, always push normal drilling. This is the kind of sentence that you need to remember. They are getting away from the origin, these ERD wells. That's the one thing. They're getting too far away, and so far that you are having trouble drilling them. You will know when you're drilling an ERD well. So they push the limits of the rig, of the drill pipe, BHAs, and whatever you will be doing afterwards, drilling. For example, if you want to run completion, completion may not be so easy to run. Before you think about drilling them, think about how would you run the completion. Can you run the completion? Are you 100% sure you can do it? If you have a doubt and you have some problem, you think it's not gonna go, do not drill it because it's going to be wasted that way. So that's the kind of thing. You need to go bottoms up. Go all the way to the end. Can you do all of the things or can you not do all the things? Don't worry about drilling just yet. Can you complete them nicely, correctly? Can you place them in the right place where the oil is or gas is? And look at the cost. Of course, you can drill anything in any shape or form by using certain technologies. Is it cost effective for you? Is it good enough? Is it cost effective? And after you finish it, can somebody produce out of it properly? Do you think it's the right thing? After you finish it, do you think it is gonna last? Average life is 25, 30 years. Of course, there will be some workovers down the road, but is it good enough? Does it have longevity? Can it last with all these $60 million investment, $80 million investment? Is it worth it, all that? Can you produce out of it? Can you do the math? So you need to And those things are usually done by the subsurface people. But drilling people need to materialize the well they have modeled. You cannot have a different well. You cannot place the well in a different place. You cannot have a different hole size than what they plan for, they ask for. They give you a target of certain well features, certain placement, certain hole sizes, certain things, certain casings, certain tubing, certain completion. If you miss one of them, the well is not going to be success. I have seen people, the whole team get fired when they did not follow. The drilling guys need to remember subsurface features, or the basis of design is your design. This is what you need to materialize. If you miss few of them because you think it's too hard or you find easier way of doing this, please don't. Okay. So that's the ERD wells thing. You go with the subsurface, which is similar to anything else. Any well, it's not your business to change it by yourself or find easier way that will jeopardize the quality of your well. You have certain KPI of the well. You have to achieve it exactly the way. Ask them what is mission critical, what is not mission critical, what is nice to do, what is mandatory for you. Can I move my target to the left or right or down? What will be the repercussion on production? And all these stories, people don't ask this question or say it's easier to hit it here. Okay, right now, let me just make it easy, drill here and do this. That's totally wrong way of doing it. That's why this discipline is all about collaboration. Collaboration starts in the planning. Collaboration continues all the way until the well is drilled and tested. So, excuse me. So just kind of word about the cost. Cost of ERD could be very, very high, but they are not as high as if you run into problems. We planned for a well $40 million once. We paid more than 80 million because we have back-to-back failures. The rig cost was $500,000 for running deep water offshore at that time, 10 years ago. $500,000 is cheap right now. It's 1 million right now, almost, after the COVID and everything. So we had back-to-back failures. Because of the failures, we mobilized the equipment, we mobilized new stuff. Before you know it, the cost escalated almost more than twice. But all these failure costs are the one that you need to worry about. I'm not worried about designing the well expensive. Sometimes you have to be on the safe side that I don't want this problem. I'm not sure if I'm going to see that problem. How about if I put in expensive technology to mitigate it? That's all right. That's cheaper actually. Because if the problem comes, you will lose huge lot of money. So that's a deal there. You need to err on the side of caution. Don't err on the taking a chance. Taking a chance is okay if stakes are not so high. If stakes are high, you will have huge problem defending it later. Why did not you do this? Why did not you do that? And there you go. And after that, you have no answer. Think about this. You are drilling in certain areas where they do not have any surface processing for sand separation or getting rid of sand from the oil. And you are designing a well in that area where they did not have a lot of problem with sanding. Sand is not coming with the oil, but would you like to have some sand screen or sand protection technology? Yes, probably yes. Because if sanding comes, the whole well will be junked. This 80 million will be gone. Why don't we use 2 million or whatever for sand screens so that if you have sanding problem coming, you are safe. So those things people have been doing for decades because they know exactly what to do. So you don't have to worry too much. When you work on ERD wells, the senior people will actually keep you right. Okay, so let's bring up ERD well. Is it worth the hassle and cost? Why would somebody go for it when they can drill simple wells and they can use less experienced people? They are half the price almost. You can use existing technologies. Everything is available. Why somebody want to bother too much about it? What's the catch? So the catch is price, surface, subsurface, because you already drilled easy to reach good pay zones. Now you have to stretch out. All the goodies are far away now. They are further in a difficult domains. So you need to stretch it to get it. Those are reaching to the prized subsurface targets. Okay. And environmental impact, footprint, CO2 emissions, land grab. If you are on land grab is a big thing. And there are communities, people living in there. Sometimes they have a school, sometimes they have ponds of water or small villages. For the land jobs, I have seen this is a problem, because some people would not probably move. If they move, they have other stuff. So if you have too many wells, there will be too much impact on the environment. Somebody could sue the company or something bad will happen to the people's health, which you don't want to be the part of. Okay. So fewer wells, you don't have to drill 2 wells, for example, for one ERD. So one could be equal to 2, depending upon where you are, how you are drilling them. ERD can replace some of the additional wells. Okay. If you have, let's say, some kind of, drilling pad, you can have 4 well instead of 6 or 8. Reduce capital expenditure. If you have 2 well versus 1 well, it will be a lot easier to maintain. The capital expenditure could be actually cheaper if you know what you're doing. Okay, especially for the offshore, it is cheaper. So let's talk about drilling from land. Some of the areas, the reservoir is under the ocean. However, you can reach from the beach. I have seen those wells in South Africa, in Mozambique. They are drilling from the beach. And in some areas, people are actually creating the islands, of course, in Abu Dhabi and other places, so that they can drill from land. They could have done from the distance, or they could have just created the artificial islands. So those are the kind of motivation. The motivation give you a big surge of profit, big surge of benefit. If there is no big surge, you should not be drilling those wells. If you're not going to get something big out of it, you should not be drilling them, because it's going to be maybe not so costly. When you design them, most of them don't look so costly. When you drill them, sometime it runs away. Sometime it becomes a train wreck. Of course, the main goal is the productivity, to get as much oil as possible. Using the single conduit is better than so many conduits, because all those conduits and connections cost money to maintain and everything. One well, if it does a lot of good productivity, why don't go for it? And the field recovery and things like that. But you need to construct the well right. Okay. Increase flow of heavy oil, which you mentioned, the faster, because if you have it designed like this, you can get the maximum benefit. Let's come back to the next one, is the various profile. When somebody say ERD, some people says horizontal well that just goes on and on in the horizontal section. Some people say, yeah, how about shallow kickoff and going at high angle forever? Very, very far, reaching far places and then drop into the target. I have seen like a S shape. ERD S shape is called a lazy S shape, because it's lazy, slowly, it's quickly built. Hold it, hold it, hold it, hold it, and then slowly turn down. Those are the very difficult wells, by the way, for weight transfer and drilling. Okay. And it could be horizontal, it could be semi-horizontal, all kind of shape and sizes of these ERD well. One thing is common in ERD well. They are going away from origin. They are going away from origin, far away, as far, how far that the TVD is half the distance of their horizontal separation. For example, this green one is 4,000 and look at the TVD around 1,200. So it could be as severe as that, or it could be the other one, which is just a kickoff and hold. Shallow kickoff and hold in the top hole maybe is a no for normal drilling. People don't want to do it. Why? Because the wellbore stability, the formation is soft. You're asking the formation to build at high angles or whatever. You have all kind of failures and problem getting stuck and everything. So it's a different methodology. Depends where you are. Geologically speaking, you choose the shape of your ERD well that suits your geological environment. If your geology supports it, go ahead, go shallow, maybe at 400 if you like to kick off. If your formation don't support it and you fight with it, you want to make it work for you, you better have some technologies. Certain technology allow you to do it, by the way. You can fight against Mother Nature, but it's going to be expensive and problematic. I have done this exercise, by the way. We kick off shallow when everything was soft. We could not have done it otherwise. We actually went for $50,000 a day RSS tool. I'm not going to mention the name. That was a specialist for soft formation. You can kick off with soft formation with that $50,000 per day tool. We kicked off nicely. The tool did what exactly it said. It was worthwhile because we were here at 800 or whatever, 1,000. We kicked off and we were like 60 or something, big number like that. Tool delivered. 50,000 is cheap. Yes, it was. If you ask anyone, any driller, 60,000, 50,000 per day is, they will not even talk to you for that. They will say you are upsetting them. It's too expensive. So it's a kind of where you are, what you have available. 20 years ago or 15 years ago, that technology was not available. I could not have pushed my boundaries like that. So you need to be aware of what is available, whether it had been successful. Right now, in ERD domain, you have so many technologies. A lot of them are not tested. They are not successful properly in terms of field tests. You don't want to be the first one. If you want to pick up a technology, it has to be used for 5 years or let's say few good field tests at least. So be aware of this as well. The new technology does not mean it will solve the problem. Maybe you will get into new problems. So you want to use something like that one, you have to pay for it, of course. It's going to be expensive. So the shape of the profile, actually, you don't pick them because you like them. You pick them to solve your problems that you anticipate from your offset well analysis. You don't pick them up because you like to build it slow and then whole. You want to go for whatever is the situation. In this situation, people use geomechanics study, people hire subsurface professionals, people hire all kind of folks to get it right. After that, they will run iterations. After the sense checks and everything, they do well engineering modeling for things. For example, shallow horizontal well, how are you going to push the BHA into the horizontal well? Suppose you are drilling the last section, you cannot even push it down from top. A lot of time is so bad because of the drag you have in the system. Are you going to overcome that drag somehow? There are technologies for it. Okay, long list of technologies. So let's keep moving. This is called nose plot. It's like somebody's nose. Okay, this nose plot is actually universal. It's available free to download, not copyrighted. I believe that's why it's available free to download. It's plotting the TVD versus the horizontal departure of ERD type wells, or most of them are ERD. Dots are wells. Dots are well. For example, at 2000 and 4000, this is an ERD, 2:1. Anything above on the right-hand side for up to this depth is an ERD well. And maybe that one as well for 8000. If you're going for 8000, these are the ERD well. It's showing the nose shape, how people have pushed the boundaries and go further and farther away using these technologies. It's just a kind of a worldwide map for ERD activities that we have been pushing, how far we have gone. This one on my right-hand side is the furthest you have gone. And while you were so shallow in TVD, for example, 25, let's say 3000, or let's say 2800 or whatever, look at this ExxonMobil Sakhalin going to 14,000 meters away from the center. That's mesmerizing, amazing, but it depends upon geology. If geology doesn't help too much, you would not go anywhere close to that number. Sometimes the formation is very competent. You can keep drilling forever, almost infinitely. It depends which formation you are in, how you are dealing with geological hazard. If it starts to hit you, there is no way you can go. You can only overcome few things. You cannot overcome all of them. Okay, so it's a kind of nice one. So let's keep going because we got few slides to present. Success factors and consideration. Choose the right rig or you go nowhere. If you have a rig that's very strong and big, it can lift this, it can apply the torque to the system. It has a powerful pumping situation, powerful pump. The rig is strong. When you do the modeling, suppose for your ERD well, it is 90% good to go. 90%, like it is okay, but there is a 10% chance that it might not be able to finish the well using the last, excuse me, let me turn it off. Sorry about that. I'll just turn it off. 2 seconds. Okay, so yeah, I just wanted to say that the rig you are drilling with should be 20% over the requirement. Margin of safety could be 20%. You cannot have the rig that is just above it or slightly above it, because you could be wrong. You could actually be wrong, and it may be exactly or below it actually. So it is something that you need to be vigilant and smart with. I have seen this in action once, and you would be surprised that we had huge problems. Everything was a problem. Surging, swabbing, and things picking up off bottom. We were worried about, we were very close to the limit. And when we pulled out of the hole, some of the connections were a little bit messed up because of the yield. It was reaching the yield of a certain, like we picked up too hard, or something was going on with the technical limits. So just wanted to say that it is important to be over designed than under designed, because that's going to be a huge problem. You cannot fix that problem. If you have a rig that's not suitable, I remember we have to stop drilling once, and everybody went home for 6 months. They removed the rig and say, bring the new rig for me because it's already drilled halfway through. And that was something you don't want to be the part of. Trajectory design. ERD trajectory is an art. You sit down with the geologists and the subsurface team. You talk them through about everything, where they want to land. Only the geologist guys can tell you where they want the well to penetrate the formation. So you start from there. Then you talk to the drilling engineer. Go back to the drilling engineer, or sit down with them together maybe. Have an iterative session. I have seen this myself. I was the well planner for some time for ERDs. So it took us almost a week, about 25 different trajectories with the geologist and the drilling team. They keep massaging the changes. They keep changing this and that. Driller people say, oh, I don't want this. It will be very difficult for me to achieve this dog leg, or this kickoff is not good for that reason. It's a long story. If you ever work for a big operator, their trajectories are revised every week, every 2 weeks, every month, sometime. Depends, more complex the valleys, they do it. But you need to learn this and say, yes, I want to make sure that my trajectory is the right one for drilling people, as well as for subsurface people. Subsurface people take the lead. If you are not placing the well right, don't drill them. As I mentioned to you early, there's no point drilling it because you are not taking them to the right place where they can get maximum production. Okay, so let's take you through to casing wear. ERD brings casing wear. A lot of them have casing wear problem. If you don't pay attention, it can eat into your casings, and then you have no well. When you have destroyed the casing because of the casing wear problem, well integrity problem comes in. How would you mitigate it? Because you want to get far away. You want to kick off this way. You have to kick off. There's no escaping from it. There are mitigation subs, mitigation techniques, mitigation fluids, some design things you can do. There's a separate topic. I can talk to you for 1 hour about this. I've done this exercise. We got rid of casing wear because we use certain standoff equipments and subs, which we incorporated to certain zones. It solved the problem. And we can check it afterwards when we run the wire line. The casing wear was not so much. Drilling fluids, there's a common sense. You are in the environment of drilling fluids. You better do a good job with it, okay? BHA design comes naturally because this is what drills. Drill pipe is the most important thing, I would say, because this is what extends all the way from surface to the BHA. If you get the drill pipe wrong, you are in a very bad luck. And same with the BHA design, you can get it stuck in no time because the BHA design can get you stuck. Okay, it's a big thing, very big thing. BHA design, you can have a course around it for ERD if you want to. Okay, so success factor and considerations, hole cleaning, you take care of hole cleaning, you place the well right. What if you cannot build? If you're having difficulty building, what are you going to do? Do you have any contingency scenario? Do you have another target you can land to? If you get stuck, what you're gonna do actually? Do you have any fishing planning? How would you fish out? Well control. It's a long list of the risk that you need to identify before you drill. If you don't identify and it comes to reality, it's going to cost you huge problems. Geological consideration, I told you about geological things. So remember this, the geology can stop you. If it's the wrong place, you can do whatever planning, whatever technology. At one point, you will give up and Mother Nature wins. Okay. The optimization side of the ERD is a fancy thing, you know. You need to think philosophically. You need to, whatever the ERD risks are on my right-hand side, let me bring up my cursor. On my right-hand side, you need to take care of things when you have not even started drilling. If your ERD has a stuck pipe problem, investigate and find the root cause. If your ERD could not build, look for the right technology. If your ERD has problem with casing wear, let's fix it in the design phase. You do all the work in the design. That's why it takes 1 year, 2 years, whatever time it takes to plug the holes. If you don't plug the hole, the hazard will seep through and come through. And the next part is real-time drilling optimization. You must monitor your well to make sure your plan is not compromised. You can compromise them and you would not know when you drill the well, you finish the well, it did not produce, it had well integrity problem or all kind of issues or too expensive. You need to use your planning guidelines to make sure that we drill the well smartly with data on your side, with visualization on your side. Okay. So you can actually use this. Okay. So I will take you through to ERD roadmap, which I think works for any complex valve. If you have any complex valve, you can use the same roadmap. Yeah, in that roadmap, it is just showing you that you have to do the digital analysis to start it. Before you start it, you have to do the digital analysis and feed the planning cycle with it. Feed the planning cycle with it and make sure that you use the red checkbox. Red checkbox means you don't want to miss out. You must do this one. And the benefit goes all the way. If you are having few of those ERD wells, then you can benefit from this. Okay. And number 5, also like this, it is showing you when you are finishing the design cycle, you may want to check on it. You may want to say, okay, this well concept, I selected for my ERD. Let's stop everything and just investigate each and every small part using data from similar wells. I want to calibrate it. I want to run simulations. I want to run risk scenarios. For example, what if I lose my, let's say, the fluid levels to this point, or cuttings are not coming upstairs, whole cleaning problem coming, what will I do? So you do this number 5 very deeply with data. The most important thing I would say is to ingest the data, run the data through the whole system. At the very end of the journey, when you are ready to drill, use the real-time drilling optimization technology, but the right one, not just monitoring for pits and well control. You want to do the proper drilling optimization, weight transfer, torque monitoring, drilling efficiencies, and things like that. I'm not talking about just looking at the pits like mud loggers, which is also fine. But for ERD, you need to be really great, because whatever you have done from 1 to 5 doesn't matter if you mess up number 6. It doesn't matter what you have done upstairs. People will laugh at you that you did the planning for 2 years and 1 year, whatever, and look at this where you are. So you don't want to be in that kind of boat where people are laughing at you for not getting it right when you are doing it. This is where bad things happen. There should not be a separation between planning and drilling. Planning and drilling, they need to be nicely merged with data as your dynamic connection. And right people doing it, of course. This is something I like to say more about this smart real-time thing. Optimization is great, but don't compromise on the well safety, common sense. And this is what I say, this is about, you bring in the data, you do the real-time drilling optimization, you make decisions based on that. This kind of things you will see. And the setup is like this. You will have back-to-back 2 engineers, and one of the engineer is their modeling guy or optimization guy. Or you don't have this third guy. There could be just 2 people. But the goal is to intervene. Whenever you see something bad is going on, you must intervene in a smart way. And you cannot have false positive. If you have too many false positive, rig will not listen to you. So that's the caveat there. Modern RTOC could offer following features. You already know it does all the tricks. It watches over everything that you have planned for. It makes sure that the plan get executed properly. Okay. And it also allows for pore pressure, geomechanics monitoring, because it's a real-time system. You can plug in smart technologies. Okay. And selection of the right technologies, you can go for something like this. You write down your challenges, you put on your options, and then you write about it, put the money on it, put if this technology gives me 1, 2, 3, 4, 5, 6, 7, 8, my concerns, my deliverables, yes or no, or you are not sure. Yes means green, you put the dot on it, put the monies on it, you can select the technology that gives you all green. Similarly, for ERDs, you can go for RSS technology selection or various technology selection, putting on your risk, what would you like it to deliver? You can have your option on the top single line, and then you can compare it with the green lights. This is called SWOT analysis, very common. Strength, weakness, opportunity, and threat. So you can play with this kind of thing to get the right things selected for your ERD. And for drill pipe, common sense is to do the proper design for the BHAs as well as for the drill pipe. For the drill pipe, the common sense say high torque, high tensile, low weights, because if you have heavy weight, it's going to get stuck or something, or high rubbing. So you need to actually design the pipe, the first thing, then the BHA, and you can do loads of modeling on the top. Okay. Final word about ERD. It's iterative process. If you want to design them, you need to be opening up yourself to first to learn about the local experience. Then you synergize it with the data technologies and data, what the data had been telling you, the offsets and everything, but not the way that old-fashioned people do. You don't need to read all the DDRs, all the end of the well reports from past. You need to use the digital things to work for you. And ERD planning is great. However, ERD execution should be also monitored with the data as your tool and visibility, and putting all the technologies into place. When you're executing them, bad things can happen if you don't monitor them. Okay. So I will stop it here. 10 minutes to go, I believe. So we can take some questions.